So in this video, we're going to be graphing something called a quadratic equation, which is this equation right here, y equals x squared. And whenever we have something that is squared, that means we're multiplying it twice. And I'll show you what I mean here. So in order to graph this equation and see what it looks like on a coordinate system, we have to make a table. And I've pre-selected what the x values we'll use to plug into the equation to find the y values. And once we have x and y's, those are coordinate points that we can plot on our graph to see what this shape looks like for x squared. Now, we've always worked with equations that are x to the first power. Like in this case, if I have an equation x plus 3, we're used to seeing, well, in this case, this x has a slope of 1 and it has a y-intercept of 3. But this x is always to the first power that we've been working with. And so now we're going to transition to seeing what happens if we make this x instead of x to the first power, but x squared instead. So let's see. If I plug in -2 and I square it, -2 squared is like saying -2 times -2, right? It's multiplying two negatives together, so that makes a +4. If I take -1, I square it, that's like saying -1 times -1, which is +1. 0 squared, well, is 0 times 0 is still going to be 0. And then if I take 1 and I square it, I just get 1. 2 squared gives me +4. So when I look at these coordinate points here, I now have my x and my y value. So I'm going to go ahead and start plotting them. So this one's at -2, +4. So -2 up 4 is right here. This one's at -1, 1. So it would be right about in here. And then we have the origin, because we have it at 0, 0. 1, 1 again, but this time it's a +1. And then we have 2, +4. So if I were to connect the dots, I start to notice I have kind of like an upside down U, and I'm curving it, and I'm making this U shape. So with quadratic equations, it makes a parabola. Let me write this out here. So we call this U shape graph or curve a parabola. And we'll use this vocabulary a lot, but it's just to describe this U shape for a parabola. For a quadratic. So when I look at this parabola or this graph here, I can see that the y-intercept, so if we look at the y-axis, it hits it at 0 for y. So I can see right here that coordinate is 0, 0 for the y-intercept. We've talked about domain before. Domain is representing the x values on a coordinate system, how far it stretches left and right. And I can see that it has arrows to the left and arrows to the right. So this arrow is going to keep going on to -infinity on the x-axis. And this arrow is going to be pointing to the right, so it's going to be going to +infinity on the x-axis. So I know that this is going to be going from -infinity to +infinity for the domain. And since I can't touch infinities, I'm going to use them as a parentheses. For the range, the lowest y value here is at 0. And we can see that this parabola is pointing upwards with an arrow. So it's going to be going to +infinity. So it's going from 0 to +infinity, parentheses. And I need a bracket on the 0 because it actually touches it at 0 on the y-axis. Another new vocabulary we'll be learning is axis of symmetry. So you can kind of see with a parabola, there's like a mirror of symmetry across the y-axis. So our axis of symmetry is going to be along right here, along the y-axis. And when we're looking on the y-axis, notice that it cuts the x-axis at x equals 0. So generally, we describe the axis of symmetry using an x value. And this is x equals 0 because it hits it at x equals 0. Sometimes you can have a parabola shift and then maybe it's laying on +3 for the x, so it could be x equals 3. But in this case, it's laying on x equals 0. So axis of symmetry uses x's to show where does the line hit on the x-axis. Okay, another thing I want to note here, when it comes to parabolas or a quadratic equation, it always has this characteristics where it points with an arrow to the right and to the left, because it needs to create that U shape, and it will continue to grow on forever as you choose more x values to plug in. So this U will keep growing upwards, and it keeps growing out to the left and right. So one of the things I want to mention is that the domain will always be negative infinity to positive infinity, or we have mentioned this before. We can also state that this means all real numbers and use the fancy R symbol. So the domain is for parabolas will always be all real numbers. So I'll make a little note here. So all quadratic equations have a domain all real numbers. Okay, so let's talk about types of solutions. Now, we've talked about types of solutions with systems of equations where there are two solutions, one solution, and no solutions. So with a system, you're looking where the two lines cross, whereas with a quadratic, you're seeing where does it cross on the x-axis. And I'll explain why this is the case that you're focusing on the x-axis. So let's pretend we have a quadratic and it crosses the x-axis, as you can see here, at 2 points. And so oftentimes when we're solving for a solution, right, or solving an equation, we're finding x. So that's why we want to focus in on the x-axis. And so we can see it crosses at 2 points, and this is where this would be called two solutions. So there are what we call two x-intercepts. So we're finding x-intercepts, and that tells us how many solutions we have. For one solution is a scenario where it just crosses one time on the x-axis. And so this here is one x-intercept, or one solution. So that could happen where it just hits the graph and then bounces back. Then there are some times where you would have a graph and the parabola doesn't even touch the x-axis, kind of like this. Maybe it's nowhere near the x-axis or doesn't touch the x-axis or crosses it, and so there are no x-intercepts. So that's why there would be no solutions. Now, I do want to mention another thing here, and I'll kind of bring it back to light later on in this chapter. But you'll notice here that I've stated real solutions. So when we're doing this interpretation, the only way we can see how many solutions there are is by looking at the graph. And so because you can actually see where it crosses the x-axis, these are what we call real solutions because you can see it on the graph. There are going to be times where you don't see the x-intercepts, but they're actually there. In fact, this one here, even though you don't see x-intercepts, you don't see where it crosses the x-axis, turns out there are two solutions. You just can't see them. And we'll explain why later. That's the case with quadratics. There's something called imaginary numbers, which we will get into, but we need to build the skills to get there. So one of the things I do want to mention is in the past, when you're solving equations like, let's bring back to light something more simple. So if you have an equation like x plus 3 equals 1, notice how this x is to the first power. If you were to solve out this problem where you would subtract the 3 over and get x, you'll notice you'll have one solution, meaning you'll just get one x value. But anytime you change the power to in this case, a 2, you've increased the power. That means you increase the amount of solutions. So because this power is 2, that is why all quadratics that have a power of 2, they will always have two solutions. But some of them you might not see on a graph. So we're going to focus today just on real solutions, the one you can physically see on a graph. Later on, I'll teach you some algebraic skills that will show you any two solutions, even if you don't see it on a graph. So let's practice finding real solutions, so finding real x-intercepts that you can physically see on a graph. So this one here for part A, we can see we have a parabola and it crosses it at 2 points. And so we need to know what 2 points they cross at. So on the x-axis here, this one looks like at -3 and this one looks at +1, I think. So we have two solutions and it looks like it crosses at x equals -3 and x equals +1. Whereas this one, it only hits it at one spot right there. So this is one real solution. And that hits it at x equals, looks like -3 to me. Oops, let me redo that. And then this one here, we can see that this parabola doesn't even touch the x-axis. So there are no x-intercepts that I can see here. So there are no real solutions here. So I'm going to just write no solution. Okay, so today's main focus is to look at how can we graph quadratic functions. And there are two ways you can graph a quadratic. There's something called the vertex form and the standard form for graphing. So there's two ways that quadratic equations can be written, but we're going to start with vertex form in this video. So something that's in vertex form is going to seem super familiar because you guys have learned how to graph absolute value equations before. Like if you had something that looks like this, you might remember like, oh, this is a -3 inside. That's where you have to shift right, and a +1 means you have to shift up when it's sitting on the outside. Well, this here is very similar to how we graph quadratics. Instead of an absolute value sign, you're going to have parentheses with the square outside. Now, because it has a square, we know we're graphing a quadratic equation. So we're going to get that U shape. But we need to understand how we're going to shift the vertex. So just as a little reminder here, here's our original parabola. And we can see that this here had a vertex, which is the middle point of the curve, and it's a minimum because it's sitting at the lowest point here. And so our vertex for this quadratic is at 0, 0. Now, we consider this type of equation to be the parent function because it hasn't been shifted. It's sitting at the origin, but when you take in a quadratic equation and you were to change the numbers like the one we can see here, like adding a 2, adding a +1 on the outside, then you have shifted the original graph for quadratics. And we're going to learn how we shift those equations. And it's very similar to what we've learned in the past with absolute value functions. So you guys can probably predict that this negative sign means you're going to be shifting to the right. Positive means you shift to the left. Positive on the outside of the parentheses is going to mean shifting to vertical, which means shifting up for positive, negative for the downshift. The A that's in front of the X is kind of like your slope, but I want you to be very cautious on how you use it. So when you use the slope or the number in front of X, you can use it as your slope, but you only want to use it 1 unit away from the vertex. So what that means is you need to make sure your slope is always over 1. Even if it was like, let me just play with this for a moment. Let's say that the slope here or the A here was a 2. Then that means that your slope is going to be 2 over 1. And so you would go up 2, but only over 1. So you can see you're only 1 unit over to the right. If your slope comes as a fraction, let's say 1/2, you don't want to use up 1 over 2 because you're 2 units away from the vertex now. What you want to do is change this to a decimal, so call it 0.5, and then put it over 1. So if you have something that's a fraction, I highly recommend you change it to a decimal and then put it over 1 because the slope always needs to be over 1 when you're doing quadratics. In fact, it should always be over 1 if you're doing any type of equation that's not x to the first power. So that means linear equation is fine and absolute value equations are fine. But anything else, you want to use this method where you always put the slope over 1. All right, so let's start graphing here. Our first quadratic equation, as we can see here, has a -2 on the inside and a +1. Now, when you're graphing quadratics, I highly recommend that you have at least 3 coordinate points. As you can see in our warm-up problem, you can see that we had 1, 2, 3, 4, 5 coordinate points, but you really just need 3. You need the vertex, and you need 2 points to the side so you can make your U shape. So I recommend having at least 3 to draw your parabola. So let's start with the vertex here by looking at the shift. So you have a -2, which means that you're going to be shifting to the right 2, and a +1 on the outside is a vertical shift up. So up 1. So from the origin, we're going to shift right 2, up 1, and plot our point. So it looks like our vertex is at 2, 1. From there, you want to use or get 2 more points to the side. And to do that, you need the slope. So the x is right here. The number in front of this x technically is a 1. So my slope is 1 over 1. Now, when I use the slope, you only want to use it 1 time from the vertex, or 1 unit from the vertex. So what I mean is I'm going to go up 1, but I'm only going to go over 1 for the run. So the run always needs to be 1. And I'm going to plot and curve to make my U. So you can see, like, because this point is higher, I'm going to be curving upwards. And then this next one here, I'm going to be going up and over to the left, but I'm going to be making that U shape, so I'm curving. So you don't want to connect the dots and make a straight line like an absolute value. You want to curve to make the U shape, kind of like a smiley face. So the line of symmetry has to be 2 in this case. Because it looks like that is the line where it cuts the parabola in half. So we have a line of symmetry at x equals 2. So I'll write that in. So our line of symmetry is at x equals 2. It looks like our vertex is a minimum because it's the lowest point on our U shape. Our Y-intercept we're going to have to find, and I'll explain here in a moment. Our domain, notice how the arrows is pointing left and right. So if you're pointing with an arrow, your domain is going to be always all real numbers. For our range, the lowest y value on our parabola is at 1. And then this parabola is pointing upwards. So it's going from 1. Let me grab this down a little bit. It's going from 1 to infinity. Bracket on the 1 because it actually touches it at 1. As for solutions, notice how this parabola doesn't cross the x-axis. So there are no solutions here. At least no real solutions. Okay, so I want to pause here for a moment before I find the y-intercept. So when I was using that slope here to go from the vertex up 1 over 1, I just want to mention that if I were to continue using the slope and going up 1 and over 1, and plotting right there and then connecting the dots, I would be very, very wrong. And let me explain why. So when I plug in 3 into the x here, 3 minus 2 is 1. 1 squared is positive 1 plus 1 is 2. And notice at 3, it does hit it at 2. But my prediction is saying that if I were to plug in 4, that it would hit here if I were to go up 1 over 1. But it doesn't, because it's a quadratic, and quadratic, anything that's squared, it grows really fast. So if I were to plug in a 4, 4 minus 2 is 2. 2 squared is 4. 4 plus 1 is 5. So that means that when this 4 is here, the y value is 5. It's up here somewhere, not down here. And so that's why you only want to use the slope 1 unit away from the vertex. Because after that 1 unit to the right and the left of it, it stops working. And that's because the square is causing the numbers to grow really fast. So just thought I'd mention that out because that's something that comes up a lot. Now let's go back to the y-intercept. So you might have remember back when we were learning x and y-intercepts, when you want to find a y-intercept, that means you want to figure out where the curve hits the y-axis. It's also where x is always 0. So an easy way to find the y-intercept is to plug in 0 for x and then find your y value. So if I were to plug in 0 for x, I would have y equals, let's see, order of operations says I have to do parentheses first. So that would be 0 minus negative 2, which is, 0 minus 2 is negative 2. If I were to square that, that gives me 4 plus 1 is 5. So when x equals 0, it hits 5. Now, looking at my graph here, I could have done a better job drawing the lines because it doesn't actually hit 5 the way I've drawn it, but it probably should have. I probably should have extended it more out this way instead of shooting upwards, but that's okay. I really just want to see 3 points on a graph, so that could be using the vertex and plotting using the slopes. All right, let's check out part. So for this one here, it looks like we have a plus 3 on the inside and a minus 2 on the outside. So that tells me we have something that is left 3 and down 2. So if I go from the origin left 3 down 2, I would plot it right about here. And that's my vertex. So this is at negative 3, negative 2 for the vertex. I don't know if it's a min or max yet without graphing the parabola, the U shape. So I need to graph my slope. So my number in front of the x is 2. So this is going to be 2 over 1. And remember, I just want to use this one time and then reflect. So if I go up 2 over 1, I'm going to go ahead and plot and then connect the dots. So let's see if I can make this a U shape. And I'm going to go the other way. So up 2 over to the left now, plot and graph. So it looks like my axis of symmetry is at negative 3. You'll also notice the axis of symmetry is using the x value of the vertex. So it splits it here where is x equals negative 3, which is also the x value for the vertex. This vertex here is a minimum. It's the lowest point. Domain is always all real numbers. Notice how the parabola points left and right. The range here, the lowest y value here is negative 2, but it's pointing up, so it's going to positive infinity. So it's going from negative 2 with a bracket, because it actually hits it there, to positive infinity. Now for the solutions, there are 2 solutions here because on the x-axis, we can see that it hits 2 points, at negative 4 and negative 2. And those are estimated solutions, so they might not be exact, but we're looking at our graph to make that interpretation. So like we've done with graphing systems of equation using that as a solution, there is a little bit of flaw in accuracy because it's based off your picture, but that's okay. We're building up our skills to learn how to use the algebra later to find the solutions. So in this case, from the picture, it looks like it's negative 4 that it touches and x equals negative 2. So I have 2 solutions. For the y-intercept, I don't know where it hits the y-axis from my picture, so I'm going to go ahead and plug in 0 for my x and find my y value. So if I plug in 0 for x and work this out, this is going to be 2. So I'm working inside the parentheses first. So 0 plus 3 is 3. If I were to square 3, because I have to do exponents next after parentheses, so please excuse. So that's exponent. If I square that, that's going to give me a 9. Now I can multiply the 9 with the 2, making that 18 minus 2 is 16. So the y value here is 16. So it turns out this y-intercept is really high. If I were to actually see it on this graph, I would have to extend my y-axis to 16 before I actually saw it cross the x-axis. So it's a little bit hard to see where it crosses. All right, from here, that is it for the vertex form. Feel free to try out some of the problems down below in the practice problems. There are still a couple ones you guys can try out on your own. All right, that's it for this video. Bye, guys.